Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. So today we're going to start with our second topic of the first chapter entitled Signal Operation. Okay, so there are two types of signal operations, which are the time-based and amplitude-based. Okay, so to differentiate between time-based and amplitude-based, you need to compare the equation with general equation. So general equation is given as y equal to xt. So you need to look at whether there's additional parameter inside the bracket or outside the bracket. So for time-based equation, so y, this is the general equation, y equal to xt. So if you notice there's additional parameters or variables inside the bracket, so it is basically grouped as time-based equation. For example, y equal to x at, or y equal to x t plus minus z, for example, or y equal to x at plus minus z or c, or whatever notation you're going to use. And for amplitude-based equation, if you notice there's additional parameters outside the bracket, for example, y equal to axt. Okay, so there's additional parameters outside the bracket, or maybe y equal to axt plus minus c. Okay, so there's no changes inside the bracket. Okay, this slide shows there's a different operation in time-based and also in amplitude-based, whether the signal being inverse, being scaled, or being shifted in time or amplitude-based. Okay, the signal also may be added or multiplied with other signal. And lastly, we're going to discuss as well the convolution. Okay, let's look at the first operation in time. So remember the general equation, y equal to xt. So when there's time inversion, so you remember you need to look at inside the bracket. So here there's additional variables or notation inside the bracket, which is negative. So negative means the signal being inverse. Okay, inverse in time. Okay, this is the original signal. So what happened when you have a new signal yt equal to x minus t? So meaning that the signal being inverse in time, but the amplitude remain the same. So if you may see, if you draw the x-axis, this is t. So now 2 become minus 2, 1 become minus 1, and here is 0, minus 1 become positive 1, and minus 2 become positive 2. So but the amplitude remain the same. Okay, so the amplitude remained as 1 and minus 1. So but now you can see that there's negative axis on the right. So you need to rearrange the axis back to original axis. So at the end you'll get the new signal y equal to x minus t. Okay, let's look at another example on time inversion. So this is the original signal. So what happened when you have a new signal equal to y equal to x minus t? So when time inversion, Okay, there's negative inside the bracket, so it's time-based operation. So what you need to do is to first draw the axis. So all positive t become negative t and negative t become positive t. So this is 3 become minus 3, 1 become minus 1, and minus 2 become 2, but the amplitude remain the same. So here and there, and the amplitude is 3, and the bottom one is minus 1. So you need to rearrange the axis back. Okay, so the final outcome will be this. Okay, so you need to flip over the negative axis to the left hand side and the positive axis to the right hand side. Okay, now let's look at the amplitude reversal or amplitude inversion. So take note, it is amplitude. When it is amplitude based, you should remember that there's no changes inside the bracket, but there's additional variables outside the bracket. So in this case, there's negative sign outside the bracket, meaning that there's inversion on the amplitude of the signal. So this is the original signal. So please remember that only the amplitude will be inverse, but the time remain the same. Okay, so you can copy the same amplitude. You can copy the same t. So 2 remain 2, 1 all is 1, 0, 1, and minus 2. But now the amplitude positive become negative. So now the amplitude positive become negative. So the signal will be down there. And the negative amplitude become positive, positive 1. Okay. There you are. So only inversion on the amplitude, but there's no changes on the time. Okay, next is time-based operation. So it's time scaling. So you should notice there's additional variation inside the bracket. So because it is time-based. Okay, but for time-based operation and for time scaling, you need to compare A with 1. Is it A larger than 1 or A less than 1? If A larger than 1, so the signal will be compressed. If A less than 1, the signal will be expanded in time because it is time-based operation. Okay, let's look at example. Okay, if you look at this equation, it's x2t. So there's additional variables inside the bracket. So it is 2. So if you compare, so in this case, A equal to 2. So A in this case is larger than 1. So the signal will be compressed or will be thinner. So this is the original signal. So with time duration of 2 to minus 2 to 2. So if the signal being compressed by how much? By 2. So you need to divide the all t by 2. So 2 become 1, 1 become 0.5. Okay, become 0.5, and then another minus 1 divided by 2 become minus 0.5, but there's no changes on the amplitude. Okay, so when A larger than 1, the signal will be compressed or speed up, meaning that the frequency is increased. So let's look at another example when A in this case is less than 1. So in this case, A is less than 1. So we should expect that the signal will be expanded in t. Okay, but the amplitude remain the same. So referring to the same original signal, so the maximum t is 2. So now how much? By how much the signal will be expanded? By 0.5 is equivalent, 0.5 is equivalent to 1/2. So the signal will be expanded by 2 times in t. Okay, so in this case, 2 become 4, 1 becomes 2, and minus 1 becomes minus 2. So all t will be multiplied by 2. So you can see that the signal being expanded in t in time domain by 2. Okay, another example on time scaling. Let's look at the first one. Okay, the first one, when x to t, look at the a. So in this case, a is larger than 1. So you know that the signal will be compressed in t. Okay, so you can just draw what happened to the t. So compressed means smaller. So here 1 become 1 divided by 2, and here 3 divided by 2, and here negative 2 divided by 2 become negative 1, but the amplitude remain the same. So here minus 1, and on top here is 3, and go down there, so the amplitude is this. Okay, so 3/2 is 1.5, and the signal being compressed in time. Okay, let's look at the second example. So now x 0.1 t. So you know that in this case the a is less than 1, so the signal will be expanded in time domain, in t, sorry. Okay, so let's draw the t. Okay, 1 by how much? 0.1 equal to 1/10. So the signal will be expanded by 10 times. So 1 become 10, and 3 becomes 30, and negative 2 become negative 20. There's no changes on the amplitude. So now the signal being expanded, getting bigger. Okay, the amplitude remain the same. Okay, so the signal being expanded. Okay, amplitude scaling is very easy. So it is amplitude based operation. So you may notice there's additional variable outside the bracket. There's nothing happen inside the bracket. Okay, so it's very easy. For amplitude based operation, it's very easy and very straightforward if compared to the time based operation. So if you have a signal given by this figure, so draw how the signal looks like, a new signal looks like when a new function given by 2xt. So that's 2, meaning that the amplitude of the original signal, this is the original signal, the amplitude of the original signal will be expanded, or will be scaled up by 2. So 1 become 2, and then negative 1 become negative 2, but there's no changes for t. So now the signal being scaled up in amplitude only. There's no changes on t. Okay, next is again in time-based operation. So you need to refer to general equation. Okay, so this is the general equation of time shift. Okay, so that's a shift of t. So in this case, remember the general equation equal to y equal to xt. So now the new equation becomes t minus t naught. So you need to remember that for time shift equation, always compare to this equation using negative. It is not positive. Okay. For example, if you have yt equal to xt minus 3, so you need to compare the given equation with general equation. So general equation xt minus t naught. Okay, so negative is there. So what is your t naught? Your t naught is, in this case, 3. It's positive 3. Okay, so in this case, when it is positive, meaning that the signal will be shifted to the right by 3. Okay, if then when you have a signal equal to ytxt plus 3, so you need to compare to general equation xt minus t naught. In this case, it is equal to xt minus, this is the original equation, minus 3 to get positive. Okay, this is positive. So what is your t naught? So in this case, your t naught is minus 3. So when it is negative, the signal will be shifted to the left by 3. Okay, let's look at example on time shift. Okay, always remember to, when you have time shifting, so you need to compare the given equation with general equation. So in this case, you have y equal to xt plus 1, so you need to compare with general equation. It is equal to xt minus, this is the basic equation, so how to get positive 1? It must be negative 1. So in this case, your t naught equal to negative 1, so the signal will be shifted to the left by 1. So shifted to the left by 1. Okay, so you can see that supposed to be the amplitude of 1 is supposed to be at 2, shifted to the left by 1. Okay, so 1 shifted to 0, and the 0 point now shifted to the left by 1, so it becomes negative 1, and so on. Okay, another example on time shift. So let's look at the equation. So xt, this is the fundamental equation. How to get positive 1? So it's positive 1. So in this case, your t naught equal to positive 1. So the original signal will be shifted to the right by 1. So how does this looks like? So 2 become 3, 1 become 2, 0 become 1, negative 2 become 0, and negative 2 become negative 1. So you need to redraw your signal on the new axis. So how the signal looks like? So now it become, 2 become 3. Okay, so you have 0, and then you have 3, and then you have 2, and then you have 1, 0, and negative 1. So 0 become 1. And then going down, this one come here. So the amplitude is the same, negative 1 and 1. So this is your new signal, okay? The original signal being shifted to the right by 1. Okay, let's look at what happened when you have amplitude shift. Okay, when you compare the general equation, you can't see any additional variables inside the bracket. So only additional plus outside the bracket. So meaning that the signal will be shifted up by B in amplitude. Okay, there's nothing or no changes on T. Right, so this is the original signal. So what happened when you have amplitude being shifted up. It is not scaled up, it being shifted up by 1. So the original amplitude 1, now the new amplitude become 2. The original amplitude at point 0, now the new amplitude at point 1. So let's draw how does this signal looks like. So everything will be shifted up by 1. So -1, now it become +1, it becomes 0. Okay, so here 0 become +1. And then here 0 become +1. So here is +1. And then going up to 1 plus 1 become 2. And here 0 at point 1. Okay, so this is your new signal. Okay, crossing at 1. Okay, so this is -1, 0, and here is 2. Okay, so what happens if you have different variable in front of x? If you have 2x, for example, if you have y equal to 2xt plus 1, so you know that the signal being shifted up in amplitude by 1, and you have amplitude scaling by 2. So what does it mean by amplitude scaling? So when you have amplitude scaling, so the amplitude of the signal now 2 times 2 become 4, and 1 times 2 become 2, and 0, and here also 2. Okay, so if you have variable in front, it is called amplitude scaling, and you have plus minus at the back outside the bracket, it is amplitude shifting, whether the signal being shifted up or shifted down. Okay, so what happened if you have multiple operations? If you have both time-based and operation-based signal in one equation. So I'll show you in next video.